This video is going to focus on, now that we know all the trig function derivative rules, how we combine them with all the other rules that we've been learning the last few days. First example, or I guess the general directions say, if you have to use any specific rule, just state it. So for part A, x squared times sine of x, we're going to be using the product rule as we go through and work with this one. So if I'm given f of x, f prime of x is going to be, remember that the product rule is 1d2 plus 2d1. So I have x squared times the derivative of sine of x, which is cosine of x, plus 2, and maybe I'll put brackets around there so we know that's all sine of x. Derivative of 1 is going to be 2x. And I am fine if you leave your answer just written like that. Second example, cosine of x divided by x. We're going to have to use the quotient rule for that. So f prime is going to be, remember it's low d high minus high d low over square the low, away we go. So I would have low d high, derivative of cosine is negative sine x, minus high, so minus cosine, derivative of low, x is just 1, and then we square the low, we'd have x squared. We could simplify a little bit here, I suppose. Let's see, did I mess something? Oh, we could bring the negative symbol right there. We could bring that up to the front. We could just get rid of the 1 there. Beyond those kind of minor cosmetic things, I'm fine if that's your overall answer. For part C, square root of t plus 4 times secant of t. First thing I might do is just rewrite it. Square roots are always kind of a pain, so that's going to be t. That's kind of a gross t. See if I can do a little bit better than that. And of course it's going to be difficult. So we're going to say t to the 1/2 power plus 4 secant of t. So for this I'd end up using the power rule. I'm going to use the sum rule. I'd use one of our trig rules. As we go through and set this up, now it's function g, so g prime is going to equal, power rule says, bring the power down, times t to the negative 1/2 power. I guess we're using our kind of our coefficient rule too. I have a 4 out in the front. And then the derivative of secant, I don't necessarily expect you to know these that well yet, but the derivative of secant is secant times tangent. Could we simplify this? Sure. This part right here we could put it at, or I guess this whole part would be 1 divided by 2 times the square root of t. All of that last part in the denominator. This we can't really simplify that much. Part D, function h now, and we're using a different variable. We're using theta instead of t or x. That's fine. You're just going to be using some different trig rules for this. So I would say that h prime of theta is going to equal 5 times derivative of secant, we just went over that, is going to be secant times tangent, and then the derivative of tangent is secant squared, so we'd have a secant squared theta there. We're using our sum rule, I suppose. That's probably as simple as you're going to get it. Part E, find the derivative of 1 over s minus 10 cosecant s. Again, this is one that I'm going to rewrite because if I can write it as a power, it's going to be a lot easier. So that first part, instead of 1 over s, is going to be s to the negative 1. I'm going to have minus 10 cosecant of s. Then we just go through and use our various rules. We'll use the difference rule. We'll use a power rule, we'll use a trig rule here. So for the power rule, let's see, this would be h prime of s. I would bring the -1 down, and then I have s, and now remember it's 1 less. Some of you are going to be tempted to write it to the power of 0, but it's actually to the power of -2 minus 10 times, and this gets a little bit trickier. The derivative of cosecant is negative cosecant times cotangent. Negative cosecants times cotangent of s. I just like using lots of brackets here just to keep things separate, I guess. That is a fine way of writing it. If you really wanted to, we can also rewrite some things just to simplify signs and things like that. So for this one, I'll just take a minute to rewrite it. This could be -1 over s squared, and then we have two negatives in the next chunk, so really I could say that it's plus 10, and then we'd have a cosecant of s times a cotangent of s. So that'd be a little bit simpler. And our last example, we have x times cotangent of x, a little bit simpler. This will be using the product rule. We do have two separate functions here that are being multiplied together. So y prime will equal 1d2 plus 2d1. We'd have x times the derivative of cotangent. Derivative of cotangent is negative cosecant squared. Plus 2, so cotangent of x times the derivative of 1. Derivative of x is just 1. And you could simplify that a little bit, not a whole lot. So that's a fine final answer right there. Okay, jot down any questions. See you in class.